Hi guys, just going to go through the maths one today. Hopefully it will help you if you've got a little bit stuck. So we've got to use these diagrams to help us solve these problems. We've got two lots of this mixed number here. So I've got two lots of 3. So that's going to be one lot of 3, another lot of 3. So I've done the 2 times 3. Now I need to do the 2 times the 4/7. So I'm now going to need to use these diagrams. 1, 2, 3, 4. I could go on to the other one, but what is helpful is if I count another 4 like this. 1, 2, 3, and then I'm going to spill over onto the next whole one. 4. So now I can count the ones I've completely shaded, which is this one now as well. 3, 6, 7 whole ones, one little one here, and there are 7 in each, so there are 7s. Same approach over here. 3 lots of 4, 1 lot of 4, 2 lots of 4, 3 lots of 4, done that, 3 4s are 12, like so, that would go in there, but then we've got this bit to do as well, we've got to do 3 lots of 3 bits. So 1, 2, 3, 1, 2, 3, 1, 2, 3. So this one's now full up. I've got my 12 I had to begin with, and another one is 13. And then I've got 1, 2, 3, 4 here. Again, one last time over here. 2 lots of 4. 1, 2, 3, 4. 1, 2, 3, 4. So I see lots of 4 done. That would be 8. Now I've got 2 lots of 6/8. So I'm going to do count 6 twice basically. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's a whole one now. So that's 9 whole ones and 4 8s. And if you really want to, you could simplify that down because that's a half, like so. Next one, solve these calculations by converting. Right, it's into an improper fraction and then multiplying. Okay, so that means that it wants you to deal with this and turn it improper. So that means that these two whole ones are each worth 7, because a whole one is 7/7 in this context. 2 7s are 14, plus the 3 on the top would be 17/7. So then what you need to do is you need to times the numerator here by 3. 3 lots of 17, you're going to need 51, 7. And that means I've got to divide 51 by 7. I can't bus stop it because 5 is already smaller than 7, so it would you just end up going and having to know your 7s anyway. If I count in 7s, 7, 14, 21, 28, 35, 42, 49. That was 7. If I'd used 49 as my 51, I'd have 2 left. 7 and 2 7. Again, wants us to go improper, top heavy. So that means we've got to do each whole one, each of these 3 whole ones are worth 4, so that's 12, plus the 3 on the top, so that's 15 quarters, times 4. 4 15s is 60. 60 divided by 4, you can do that with a bus stop, it will help. Let's say 15. Okay. Right, now the submarine, we'll notice it's got a little bit deeper, okay, so it's going to get a little bit trickier. So I'm allowed to spend up to 1 hour watching TV in the evening. Lovely. On each Monday, Wednesday and Saturday, I spend 50 minutes of my allowed hour watching TV. Which diagram and calculation correctly represents the time I spend watching TV each night? Okay, so this one over here says that is 3 lots of 5/6. That's basically what they're saying. This one is saying it's 3 lots of 3/4. So we're really trying to find out this 50 minutes. That would be 50 out of an hour. And an hour is worth 60 minutes. So we know if we simplify this down, I could divide both of these by 10, and we would get 5/6. 3/4 of 60, I halved it, would be 30, and then I half those halves, there'd be 15s, and then it wants 3 of those 4, they would add up to 45, not 50, okay? Next one, which multiplication is the odd one out and why? So we're going to have to just multiply them all out, and then at the end look at the answers and figure out what one that might be. So I'm just going to stick with the method of doing the whole number and then doing the fraction rather than top heavy, because these numbers are quite big, so we'd end up with huge numerators. It's going to be 10, it's going to be 26, yes, which is 3 and 2, 6. Might need to simplify the fraction at the end, we'll see. Next one is going to be 5 times 8 and 5 times 2/3. 5 8 is 40. 5 blocks of 2 are 10, so figure out the numerator, which will be 3 and 1. And then I need to put it together, so it's going to be 43 and a third. I was a bit naughty, but to do that back here. I know that's something that a lot of us have been doing this week, so it's probably nice for you to see I've done it too. If I did simplify this, these 2/3, it would, 2/6, sorry, it would be a third, like so. And then lastly, 5 4s are 20, 5 blocks of 4/5 are going to be 20/5. We can use that table back to help us, which is going to be 4. Make sure I pop them together, like I didn't do last time. 24. So we can look here, we can see that the calculation of the odd one out is the one on the end in green, 24. It's the only one that has an answer that's a whole number. And the other two also have fractions that are the same at the end. Okay, they've both got a third. Right, and now as we see, our submarine is right at the bottom of the ocean, so these are the trickiest ones. So the school cook is working out how many potatoes she needs to buy to cook dinner for the school. She estimates that each class will eat 3 4/7 kilograms of potatoes. Crikey. She buys 21 3/7 kilos of potatoes altogether. How many classes is the school cook buying the potatoes for? Right. So it basically wants to know, 4 times something equals 21 3/7. So I'm going to use a bit of estimation here. So I know I've got 3 and a bit and I've got to get up to 21. I know it can't be 7 at the moment, because if I did 7 lots of 3, I could get to 21, but by the time I've done 7 lots of 4/7, it would take me miles past this. Okay, it's already would be past that with one of them. So I'm going to check 5. I think 5 will probably be a bit too small. It's either going to be 5 or 6. So let's check 5. 5 lots of 3 and 4/7. So that's 5 3s, 15, the whole one. 5 lots of 4/7 are going to be 27. Going to be 2, 6, which doesn't work. It's going to be 17 and 6/7. So it's probably going to be 6. I'll just check. I know it's going to be 6 because, like I explained before, it'll be far too big for 7, but I'm just going to show you and prove that that's the case. 6 3s are 18. 6 lots of 4/7 are going to be 24. Okay, 3 3 7. Pop those together. So, okay, you could do 21 3/7 divided by 3 4/7, but that would be a lot trickier. Right, lastly, use each of the digits 1 to 6 only once investigating these statements. So there could be different ways of doing this, different answers. I'll just show you a couple. So it wants something, so it's a whole number times mixed number. And it wants the greatest possible answer. So if I want the greatest possible answer in these questions, I'm always going to have to put the digits with the greatest value first. So that's going to be 6 and 5. Okay, 6 and 5. So from there, I need to make this fraction as big as possible, but it says don't make an improper fraction within a mixed number. So what we know is we've got 1, 2, 3, 4, 5, and 6, but we've used these ones here already. The largest the largest proper fraction I can make would be to put the 3 on the top and the 4 on the bottom. I believe that's the largest one you could make. So the next one, something, again, we've got the same combination here. So a mixed number answer with 1/2 as the fraction. Right, well, it probably makes sense to put the half in there already. And for this to work, we're going to need to put an odd amount somewhere, okay, so that this could work. So let's imagine, let's see what would happen, okay, if we put in a 3 and a 4, for example. So 3 lots of 4.5. 3, 4 is 12. And then by doing an odd amount of halves, it's going to ensure that you're always going to have that half dangling off the edge, so to speak. If I had put like 2 even numbers in here, like if I'd gone for the 6, for example, then this wouldn't work because 6 times 4 would be 24, and 6 halves give you an even amount of halves is going to give you an actual whole number. So therefore, you're not going to end up with this bit dangling off the edge. One of the numbers in here has to be odd, and one has to be even, because odd times even gives odd. 2 evens won't work, and nor will 2 odds. Odd times odd gives odd. So it could give 1, try it with 1 and 3. 1 and 3. 1 lot of 3.5 is obviously going to be 3.5. We've used the 1, so we could do it with 5. 5 times 3 is 15, and then 5 halves is going to give you 5 halves, 2.5, which gives you that little bit dangling off the edge like I was talking about. Okay, so as long as you don't put 2 even numbers into the whole number boxes and you keep the half in the end,